All right, 8th grade, here are your directions for the How Low Can You Go lab. So we've been dealing a lot with boiling of water and freezing of water and looking at the phase changes as you go from solid, liquid to gas. Well, we're going to look about how cold can you get something to freeze at. So it's been found by experimentation, and fill in the blanks as we go, that all solutions made of a solid dissolved into a liquid, usually that liquid is water, will boil at a temperature that is higher than the boiling temperature of the liquid alone, and it will freeze at a temperature which is lower than the freezing temperature of the pure liquid. Scientists call this phenomenon freezing point depression. So your freezing point is depressed, it goes down. You kind of think if you're depressed, if you're sad, that means down. So your freezing point goes down. The temperature at which you freeze at goes down, is lowered, okay? And we call it boiling point elevation, because to elevate something means to go up. So here's my little mountain, a high elevation, kind of a bad drawing, but boiling point elevation, because your boiling point, or the temperature at which you boil, is elevated, is going up. Okay? So this explains why in the winter we put salt on the roads when it's starting to get icy, or when we put, sometimes cooks will put salt into your water when you're boiling it for spaghetti. So in the winter, we put salt, it's technically magnesium chloride. Sometimes you'll hear on the news them use that term, magnesium chloride, placed on wet roads right before it's about to freeze, okay? And so if they put it on right before it about gets to that freezing temperature, the solid salt will mix with the water on the roadways and form a solution, and so the freezing the temperature at which will freeze or ice over on the roads is actually lowered. So this means the temperature will have to drop lower, or it'll have to get colder before the roads will be covered with ice. So it has to get a lot colder before the roads get icy. When you cook spaghetti, a lot of times you might see your mom, or you might do it, you put some salt into the water as you're heating it up to boiling temperature. What that does, it creates a saltwater solution which now boils at a higher temperature than it normally would. So when you put your spaghetti in, you're putting it into water that is actually hotter. Oh, it was my really bad flames. Hotter than the normal boiling tap water. And so if the water is hotter that you're putting your spaghetti in, it can actually cook faster. So raising the boiling point makes it boil at a higher temperature, and so it can cook faster. So in this experiment, we have about 4 different parts. First part is you're going to find the normal melting temperature of ice. What temperature does it normally melt at? Then we're going to add salt to the ice, which should do what? It should lower the temperature at which it melts, freezing point depression. Then you're going to create and test a plan to try to get the coldest melting temperature that you can, and then we're going to have a little contest. We're going to see who can actually come up with the coldest melting temperature. So we're going to use the LabQuest again. And so first off, you have your LabQuest, and you just need to attach your good old temperature probe to the LabQuest again. And on the meter screen, you're going to press rate, and you're going to change the data collection to 0.1 sample per second. Remember, when you change that to 0.1 sample per second, it's automatically going to change how many seconds per sample automatically for you. And our data collection length is going to be 600 seconds this time, about 10 minutes. All right, so then I'm going to give you some crushed ice. We're going to put about 100 milliliters of crushed ice into a 250 milliliter beaker. Put the temperature probe in the ice and start your data collection by pressing the play button. You're going to hold the beaker in one hand, and what do you think your hand is providing? Heat to allow the ice to melt, okay? And we're going to record the temperature as it melts, as it's displayed in your graph. Then I'm going to give you a sample of 5 grams of salt. You're going to put it in and continue to stir until the temperature stops dropping. Remember, when the temperature is constant, that's when the melting is occurring. And record the lowest temperature reached. And when the temperature stops dropping, press stop on your data collection, and you can look at your table screen and record the lowest temperature that you found. Now part 3, you're going to work with your lab partner and you're going to come up with some sort of plan to try to get the lowest temperature possible. You can use as much ice water as you want. You're going to use a 250 milliliter beaker, but you're only going to have 5 grams of salt. I already have it weighed out, so everyone only has 5 grams of salt. So depending on time, I'll give you some time to maybe test a few hypotheses, see how you're doing, okay? You're going to explain your plan in your data section. And then we'll have a contest. We'll put everything together and all at the same time we'll try to reach the lowest temperature and we'll see which group does the best. Again, you can have as much water or ice as you want, but you can only have 5 grams of salt. So you got to decide, do you need more ice, less ice? What do you think? So that is your experiment for Friday. See you then. Bye.